Welcome to a lesson on the graphs of sine and cosine functions. In this lesson, we're going to kind of shift gears a little bit. We're going to move away from thinking of sine and cosine in terms of the unit circle. We'll start there, but we're going to try to move away from that. Move away from thinking of it just in terms of acute angles of right triangles. And we're going to think of it more as an algebraic function. So if you were to graph the sine and cosine graphs using like a parabola or an exponential function, if we were to graph it on an x and a y axis, if we were to think of them as more of an algebraic function. So specifically, we want to at least be able to draw one period of either graph, sine or cosine. We also need to look at the transformations. If you remember transformations from your pre-calculus algebra, that's where we would have talked about like a horizontal or a vertical stretch, a horizontal or a vertical shift, or a horizontal or a vertical reflection. And there's others, but those are kind of the main ideas that you would have seen in your algebra class. And so we're going to talk about those here. We call them amplitude, period, phase shift, and vertical shift. And then we'll look at sort of this idea of 5 main points. There's 5 specific points on either graph, sine or cosine, that kind of give it its shape. And then we'll look at let's do the reverse. What if I give you the graph? How do we write the equation? All right, so let's first start with just what do the graphs of sine and cosine look like if we think of them as an algebraic function. So I have a little GeoGebra applet, a little graph that we can look at. Okay, so on this graph, I have the unit circle here. So this is the x-axis and the y-axis. The unit circle is centered at the origin. Its radius is 1. And I have a point, and we've been talking about this. I have a point located on the unit circle. So right now this point is at the coordinate 1, 0. And then I have angle theta up here, and right now it's at 0 radians because our point is on the x-axis. So as this angle increases, so as it starts from 0 radians and it goes to 1 radian, 2 radians, up to pi, and then all the way around to 2 pi, as that angle increases, what's going to happen to this point? Okay, so let's just track it. Again, this should kind of make sense. As the angle increases, our point rotates around the circle. Okay, so that's kind of what we want to look at. And notice as it rotates around, the x and the y coordinates change. So if we looked at a 45-degree angle, I can find it here. There we go. So that's 0.79 radians. That's pi over 4 if you computed it as a decimal. We get 0.71 for x and 0.71 for y. Well, 0.71 is the square root of 2 over 2 as a decimal. Okay. If we keep rotating, if we rotate it to pi over 2, so 90 degrees, that's 1.57 radians. Again, we get 0, 1 for the x and the y, and then we can keep rotating around. Notice once we get into the second quadrant, again, the x coordinate should now be negative and the y coordinate should be positive. And it's going to continue rotating around. All right, so now let's connect that unit circle with our sine and our cosine functions. So remember, sine represents what? It represents the y coordinate. So that means at 0 radians, the y coordinate is 0, which means sine should be 0. Okay, it's kind of hard to see here because the coordinate overlaps, but we have an x coordinate of 0 and a y coordinate of 0. The x coordinate is the input. It's the theta. It's your angle at 0 radians. The y coordinate is the sine value, so it's 0. So as we increase our angle here, hopefully it'll make a little bit more sense. As our angle increases, the y value is increasing. And so the sine function has the same height. So if we keep going here, and we keep going, notice at this coordinate here, the sine function has a coordinate 2.44 and 0.64. Where does that 2.44 come from? It's not from the coordinate on the unit circle. It's the angle that we're talking about. So the angle, whatever angle you're talking about, it's just a number, it's a real number. That is the input, the x value of our sine function. So it's the input, it's the x coordinate of our algebraic sine function. Well, what about the y coordinate? Where does this 0.64 come from? That does come from the point on a unit circle, and it is, again, it is the y coordinate from our unit circle point. And so as we keep rotating around, we get down here into the third quadrant. Again, the 4.19, that is the angle, that's our input. The negative 0.87 is the y coordinate on the unit circle. And so we can kind of continue going around. And when we get to the end of the circle, the end of our one revolution around the circle, we have 6.28 as the x coordinate. That's 2 pi. That's our angle. And then we have 0, that is the y value. So let's trace this out and see what it looks like. So all of these points on our sine graph here represent, if you looked at each coordinate has an x value that corresponds to the input angle as we rotate around the circle, and the y coordinate is the y coordinate from the unit circle point. And so as we keep going, we just rotate around. So what we end up getting is this sort of elongated, it's almost as if you took this circle and kind of unrolled it, right? So the first part of the curve is sort of the top half of our circle, and the second part of the curve is like the bottom half of our circle. So it'd be kind of like you unwound this circle and just stretched it out. So that's what our our sine graph looks like. So the x value of your sine function is the angle, the input value, and the y coordinate of your sine function, the value of this function itself, is the y coordinate for the point on the unit circle. All right, so what's cosine look like? All right, so remember, cosine is the x coordinate of the point on the circle. So right now, when we look at 0 radians or 0 degrees, we should have a cosine value of 1, which is what happens. So if we look at cosine, the value, the input of our cosine function is 0, which comes from the 0 radian angle, and the 1 is the x coordinate from our point on the unit circle. As the angle increases, what's going to happen to the x coordinate? It's going to get smaller, and then it'll go to bigger, but in the negative direction. So let's see what happens. As the angle gets bigger, as our angle is getting bigger, the x value is getting smaller. So as the angle gets bigger, the x value is getting smaller. The weird thing here, though, so again, the 0.52 is your angle. The 0.87 is the x coordinate from the point on the unit circle. But when we graph it as an algebraic function, this 0.87 is actually a y coordinate. So it's kind of weird, but it's the cosine value at 0.52. Okay, and we can continue going. So cosine has a very similar shape to sine. It just starts at a different place. Okay, and it's actually shifted. Both of these graphs have the exact same shapes. They're just shifted a little bit. Okay, maybe we'll see that here in a little bit. Okay, so again, sine, the value of your sine function represents the y coordinates on the circle. The value of the cosine functions represent the x coordinates on your unit circle. So now that we've looked at those two graphs, let us just draw each function, what its basic shape will look like. So if we talk about the function, think of it as an algebraic function, f of x is equal to sine of x. Okay. Sine starts at the origin, goes up, down below the x-axis, and then back to the x-axis. The highest it goes is a positive 1, and the lowest it goes is a negative 1. And it does all of this from 0 to 2 pi. Okay? Cosine, let's look at what cosine is going to be like. Cosine f of x is equal to cosine of x. Cosine started at the top at 1, goes down, and then back up again. So cosine, the highest it still goes is 1, and the lowest it goes is still a -1. And it does all of this process, all this part of the graph, from 0 to 2 pi. Okay? So these are what the basic two graphs look like, sine and cosine, and we need to know what they look like. You can also reflect them, but we'll get into that later. And then there's 5, we talk about these 5 points. So for sine, the 5 points would be the starting point and the ending point, which are both on the x-axis, and then the middle point, which is where it also crosses the x-axis. So I have 3 places for sine where it crosses the x-axis. Where do you think the other 2 are going to be? Well, one is up here at the maximum, and then the other is at the minimum. Okay? If we were to, and these are all evenly spaced, so if we're going from 0 to 2 pi, the middle happens at pi, the maximum happens at half of that, so pi over 2, and then the minimum happens at 3 pi over 2. If we kind of look at cosine, so again, 5 points. We have the starting point, we have the ending point, the 2 maxes. What happens right in the middle? Well, we get a minimum. Okay, so we have 2 maxes and a min. Where are the other 2 points? Where it hits the x-axis the first time and then the second time. And the spacing again is even. So this is at pi. This is pi over 2. Oops, pi over 2. And this is at 3 pi over 2. Okay, so those are sort of the 5 main points that we kind of want to think about. And once we get into graphing the functions and stuff, we'll actually look at how do we write the coordinates for those points. I guess if we wrote those points out here, at 0, we have 0, 0. At pi over 2, we have 1. At pi, the value of the function is 0. At 3 pi over 2, it's down here at the minimum, so it's a -1. And then at 2 pi, it's back to 0. So those are the 5 points for the standard sine graph. For cosine, it's at 0. So 0 is the x, the first coordinate. It's the first x coordinate. So it's 0, 1. The next one again is at pi over 2, but now it's down to 0, the y value. And then the third one is at pi, and at pi the function is at a -1. The next x coordinate would be 3 pi over 2. At 3 pi over 2, we're back to the x-axis, so that's y equals 0. And the last one is at 2 pi. Again, at 2 pi, we're up at the top, so we have a 1 again. So those would be the 5 main points for our sine and cosine functions. And as we're going to get into transformations here in a minute, we need to look at how do those 5 points change. All right, let's look at our transformations, and there's 5 ones that we're talking about. And again, these are the same transformations that you talked about in your algebra class. We're just giving them different names: amplitude, reflection, period, phase shift, and vertical shift. And just to kind of explore this a little bit, I have this, again, another GeoGebra graph that we can look at. So there's several ways we could write what the formula looks like for these graphs. And I've tried to write one that would be similar to what you saw in your algebra class. So I'm just going to look at sine here. Cosine does the exact same thing. So we could think of sine as y equals a, some constant a, times the sine, and inside the sine, inside the parentheses, we're going to have another constant b, times another parentheses, x minus h, and h is a third constant, close double parentheses, and then plus a fourth constant k. Okay, so we have 4 constants, a, b, h, and k. A and b are multiples, h and k are additions or subtractions. Okay, and so you may already know where this is going if you remember your transformations from 171. But right now, the a and the b are both 1, so we have just y equals sine of x. If if you got rid of the ones and the zeros. It's just y equals sine of x. So this red graph here is y equals sine of x. And if you started at the origin, it goes up to 1, down to 0, down to -1, and back to 0 at 2 pi. So that is sort of one loop around the unit circle. Now in fact, when we talk about our trig functions, we call that a period. So it's one complete loop. Okay. The rest of this graph. So if you look to the left of the y-axis, this is just a copy of this part of the graph. So if you have one period of the graph, so from 0 to 2 pi, you could copy that and paste it to the left and to the right forever, and you'll get the whole graph. Okay, and we can do that because we keep going around the unit circle forever. Remember, rotation is unlimited. All right, so what do these four constants do? So let's start with a. If right now a is 1, so if a gets bigger or smaller or positive or negative, what happens? So as it gets bigger, what's happening to our graph? It's making it taller, right? Now it's not moving the graph. Okay, it's still hitting the x-axis at the same place. It's just making it taller. So in your algebra class, you would have called this a vertical stretch. What happens if it gets smaller? Well, it's going to make it shorter. So you have that vertical stretch, or I guess maybe a vertical compression. What happens if it's negative? So if it's negative, it reflects it. Okay, so the a value has two things that it does. It could make the graph taller or shorter vertically. It could also reflect it over the x-axis. And so that hits two of those 5 transformations. One is the amplitude. A is for amplitude. And so it tells you how tall the graph is. And then it also tells us whether it's reflected or not. That can work. All right, so let's go back to 1. Okay, so what's B do to the graph? A makes it taller or shorter or reflects it. What does B do to the graph? As A gets bigger, what's happening? Let me say A at 2 here. Or sorry, B at 2. Normally, the graph starts at 0. One period starts at 0. It goes up, down, and back to the x-axis between 0 and 2 pi. If B is 2, what's the red graph do? It starts at 0. It goes up, down, and back to the x-axis, but it does it all between 0 and pi. So it's actually shrunk. It's made the period shorter. It's made the graph shorter. I can actually, if I went from 0 to 2 pi, I can actually do this complete loop, this complete cycle, twice. Okay, so it's making the graph shorter. Not vertically, but horizontally shorter. What if we made B, what if we made it 3? Okay, so how many times can I fit one loop in between 0 and 2 pi? So up, down to 0, up, down to 0, up, down to 0. So I can fit it between 0 and 2 pi 3 times. What if I did B is equal to 4? So it's up, down, up, down, up, down, up, down, back to the x-axis. I can do it 4 times between 0 and 2 pi. Remember, 0 to 2 pi was the normal standard period. I can now, if B is 4, I can now fit the wave cycle, the wave period within the standard 4 times, which means each graph is now 1/4 or 1/4 of its original length. So if I originally am going from 0 to 2 pi, I'm now just going from 0 to 1/4, so 0 to pi over 2. Okay, so the bigger B gets, the shorter horizontally your graph gets. And same thing if B gets smaller, if it goes closer to 0, your graph is going to get longer because you're stretching it. It's sort of an inverse direction. If B is negative, it will have an impact, but we're just going to assume B is always going to be positive. Okay, remember, I guess technically, remember sine is an odd function. We talked about this in the last lesson. If B is negative, you can take that B and throw it out front. Put it with the amplitude. But again, I don't think we're really going to worry about that. So A is the amplitude. It tells you how tall the graph is. It also tells you if there's a reflection. B tells you the horizontal length. How long is the graph, or how short is it horizontally? So what's left? Shifting. Okay, so all that's left is h and k, and hopefully you might remember this. What do the h and the k do? So h, notice inside the parentheses, it's x minus h, which right now x minus 0 is just x, so it starts here as it normally does. What happens as h gets more and more positive? You can kind of see it, the graph is shifting to the right. Okay, hopefully again you kind of remember this idea back when you had your transformations in your algebra class. As the graph, if you have x minus 2, say, if you had x minus 2, that means the graph was shifted 2 units to the right. So you do the opposite sign. X minus 2 means the graph is shifted 2 units to the right. So that means if I started my sine graph, it would start here where it hits the x-axis. It starts 2 units to the right. It goes up and down and back to the x-axis. So what happens if h becomes negative? All right. Well, now, let's say it's a negative 4. Well, what's x minus a negative 4? X minus a negative 4 would look like x plus 4. So if you have an x plus 4, that means you're shifting 4 units to the left, which 4 units to the left would be about right here, about halfway between negative pi and negative 3 pi over 2. Not quite halfway, but so if we started here where it hits the x-axis, we go up, down, and back up. That is 1 period. Okay, it's starting 4 units to the left. All right, so again, this horizontal shift, and when we talk about trig functions, instead of saying horizontal shift, we're going to call it a phase shift. Okay, it's changing the phase of the function. All right, the last thing is, and probably the easiest, or one of the easiest ones, is k. So k is the number you're adding on at the very end. What happens if k gets bigger? The graph goes up, and if k goes negative, the graph goes down, right? So k is your vertical shift. So k is the vertical shift, h is the horizontal or phase shift, b is the length of the period, so it's the horizontal stretch, a is the amplitude, it's our vertical stretch. Okay, so now that we've kind of explored what the graphs look like, let's look at how do we go about drawing these graphs. So there's a couple, and we'll do both a sine example and a cosine example. We'll just start with sine here. There's a couple ways you may see the function written, depending on what web page or textbook you're looking at. But this is the first one here is what I've showed you on that previous graph. So y equals a sine of b times the quantity x minus h, close parentheses, plus k. All right, so the a was the amplitude, that's the vertical stretch. B is the horizontal stretch. H is the phase horizontal shift. K is the vertical shift. Now, some textbooks may get rid of the inner parentheses and they distribute the little b. So I've also included that here. A, capital A, sine of capital BX minus capital C, close parentheses, plus D, capital D. The A, capital A, and little a are the same thing. They're both amplitude. Okay, capital B and little b, same thing. They both represent the horizontal stretch. K and capital D represent the same thing. It's a vertical shift, up or down. So the only thing that's really different here is the H and the C, okay? Because the H involves a factored parentheses, we factored this B out. If you kind of wanted to go between either of these two, one way you could do that, if I were to distribute this B into the parentheses and multiply it by both of those, I would get BX minus BH. So it's this BH that represents C. So C is the same thing as BH. Or if you wanted, you could say H is C over B if you just divide the B into that. So that just gives you sort of a relationship. They're the same function, just written slightly different. So how do we go about graphing? And again, you may see different strategies for this. This is just kind of one of the ways that I've approached doing it. So the first thing that we need to do is figure out where's the graph going to be centered. and that's the horizontal, like vertical center. Okay, so if you drew a horizontal line through the center of the graph, that's what we're talking about, and that is at the value of k. It's our vertical shift. Normally the graphs are centered on the x-axis. Okay, normally it's centered on the x-axis. Okay, but if we shift it up, it's no longer the x-axis. It's going to be moved up or down. So we need to know where is that located, and it's just the k value. All right, it's this vertical shift. We then need to know how high is the graph. That's our amplitude. Now technically the total length of the graph is double the amplitude. Okay, so from top to bottom it's double the amplitude. So that means from the center line, or sometimes you may hear that called midline. You may hear that. This is the midline. It's a units up and a units down. So the amplitude represents half the total distance. It's from the middle to the top is the amplitude, and then from the middle to the bottom is the amplitude. So if we know the middle, we can find the top and the bottom. The next part that we need to figure out is where's the left edge of our graph. So I'm creating this box here is the idea. The left edge of the box occurs at wherever the vertical or wherever the phase shift is at, whatever h is. Okay, and it can be positive or negative. In my illustration, it's a positive value, but that's okay. So the left edge of the box is at your h value. The next part is where is the right edge of the box. Okay, so what is the total length of the box? Normally, the total length of your one period is all we're drawing here. The length of one period is 2 pi. But what affects the period? Which letter affects how long horizontally the graph is? B. Whether little b or capital B, doesn't matter. B affects the overall shape, the length of your graph. So to figure out the right edge of the box, we are going to take h, which is our left edge, plus 2 pi over b. Okay, and we call this whole length from here to here, we call this the period. Okay, and that's because the period, and this is an equation you're going to want to know, it's 2 pi over b. Okay, the period is 2 pi over b. So if you know the graph starts at h and you know its whole length has to be 2 pi over b, then h plus 2 pi over b will get you on the right edge. Okay, and then we can also sort of divide up our function or our box into 4 parts, which I've shown down here on the x-axis. So there's 1, 2, 3, 4 little sections between the left and the right endpoint. Why are these 4 little sections important, and these 4 little parts? Well, if there's 4 little parts, how many tick marks are there? 1, 2, 3, 4, 5. Why is that important? Well, remember we had our 5 points. So and they're all evenly spaced. So by knowing where those 5 tick marks are, I know where the middle of the graph is going to be. I know where the left and the right edge, and I even know where the maximum and the minimum for sine is going to be. So once we know what the box looks like, we can go ahead and we can draw the sine graph into it. And remember, this little wave here that I've drawn, this is the default sine graph. Okay, we drew this. This is what we drew a few screens ago. Right, this is what we were looking at on that first graph. Okay, so we're drawing it from here. It goes up and around. Okay. Now, the only thing that might change is if your amplitude was negative. If there's a negative on your A, it's possible that you might have to draw this as a reflected graph. So it's just going to be upside down. But again, it's still going to hit the maximum back in the middle, the maximum, and then on the end point. So it's still going to have 5 points. They're just the maximum and the minimum flip. Okay. All right, let's kind of look at the same thing with cosine. So cosine, it's the exact same setup. The equation's the same. It's just cosine instead of sine. You have either variation of the equation, whether it's A, B, H, and K, or A, B, C, D, doesn't matter. The letters are themselves are irrelevant, just you need to know the format. We're still going to draw a box. The center, the midline, is still at y equals k. It's still got a height of 2, which means from the middle to the top is a, from the middle to the bottom is a. The left edge is still at h. The right edge is still at h plus your period. So again, the whole length from here to here is your period. And our period we could compute as 2 pi over b. And then we're going to divide it into 4 parts again. So we have the 1, 2, 3, 4, 5 tick marks. All right. So once we get the box set up, just draw in your cosine graph. So again, the cosine graph started at the top, goes down and back up. Okay. And if it was reflected, you're going to flip this whole graph upside down. Okay, so that's what the reflected graph would look like. Okay, so that's sort of the basic process. Let's look at a few examples here. All right, so we're trying to draw the graph of y equals a -2 times the sine of 2 pi over 3 times the quantity x minus 1, and then plus 3. So we want to draw the graph, and we want to list out the 5 coordinates. So to go through our process again, we want to draw that box. And so to draw the box, the first thing we need to figure out is where is the middle, the center of the graph. So let's talk about this midline. Okay, the midline is at y equals k, which in this case, k is 3. All right, so that means if we just go in normal tick marks, so 1, 2, 3. So somewhere on this line, that's the middle of my graph, y equals 3. Okay, and we can also go to the left if I need to as well. Once we do the midline, let's look at our amplitude. I'll leave that there. Amplitude. So the amplitude is the a value. So a is equal, and we're just going to ignore the negative for the moment. We're just going to say it's a equals 2. So that means from the midline, I'm going to go 2 units up. So from here to here is 2 units, and I'm going to go 2 units down from there to there. Okay, so that means the box, the top of the box, where's that at? That's up here at 5, and at the bottom is down at 1. Okay, so we now have the middle, we have the top, we have the bottom. So where's the left edge of the box? Okay, the left edge occurred at the x value of h. And what is h in this case? So h, so again, this is a, this is b, this is h, and this is k. Now why am I using h and k instead of c and d? Is because I have this factored parentheses here. If there's middle parentheses wasn't there, it would be c and d. So in this case, it's x minus h. So h is 1. So I'm going to start my graph, my box, at x equals 1 here. Okay. All right. And then we got to figure out how wide, how long is the graph, and that's where we're going to look at the period. So the period is 2 pi over b, which is 2 pi over 3. To simplify this, we're going to dividing a fraction is multiplying its reciprocal. So 2 pi over 1 times 3 over 2 pi, which the 2 pi's cancel, and you're just left with a 3. So the length of the graph is 3 units long. So if we start at 3, or sorry, we start at 1, we're going to go 1, 2, oops. I'm going to go, so if we started at the graph at x equals 1, we have to go 3 units. So 1, 2, 3 units away. So the graph is going to end at 4. Okay, so here's my box. Okay, all right, we're not going to draw. So here's the box that we have here. So the top is at 5, bottom is at 1, the left is at 1, and the right is at 4. Okay. We also need to divide this from 1 to 4 into 4 equal parts. How wide is each part? If you take the period, it is going to be the period divided by 4th. So each little tick mark is going to be 3/4, 3/4 of a unit. So we're actually going to have one here, one there. Whoops, we're short one. One, two, three. Yeah. So we're going to have one at 1 3/4. We're then going to have one at 1 1/2. And then, sorry, that's not 1 1/2, that's 2 1/2. And then we're going to have one at 3 1/4, and then 4. So we have 1, 2, 3, 4 sections, and we have 5 points, 5 tick marks. 1, 2, 3, 4, 5 tick marks. It's a little hard because the tick marks aren't. It's not a nice even whole number width, but sometimes that happens. All right, so now we need to draw in our function. Let's go back up here. Remember, what does that negative tells me? It tells me the graph is reflected. Okay, so normally I would start in the middle and go up, down, and back up. But instead, because it's reflected, I'm going to go down. I'm going to hit the minimum on that first tick mark. I'm going to come back to the middle line in the middle. I'm going to hit the maximum at the next tick mark, and then I'm going to hit the midline again at the last. So my graph is going to look kind of like this. And again, it should not be just a bunch of straight lines. It should be a nice sort of smooth curve. So again, this is the reflected graph of sine. Normally it started here and goes up and then down and back up. But again, because that negative is there, we have to flip it upside down. Okay, and so this is what our graph looks like. So let's go ahead and list out our 5 points, and we'll just go from left to right. So the first point occurs when x is 1, and the y coordinate is 3. Does it do that? Okay. The next one, so there's the 1, 3. The next one is at 1 3/4, because each one of these is going to be 3/4 units apart. 1 3/4, and its y coordinate is down to the 1. The third one is at 2 1/2. I'll write that as a fraction, but you can do a decimal if you want. And its y coordinate is back to 3. The fourth one is 3 1/4, which again you can write that as a decimal, that's fine. And it's up at the 5. And then the last point is at x equals 4, y is equal to 3 again. So those are the 5 points that we have. All right, let's try another one with cosine this time. So we have y equals 4 cosine of the quantity 2x plus pi, and then minus 2. So right now, the way that this is written, since there's no internal or inner parentheses, this is the A, capital B, capital C, and capital D format, which I would prefer to factor this. So I'm going to rewrite this as 4 cosine, and then inside our first parentheses, we're going to have a 2. So I need to factor a 2 out of the 2x and the pi. So if you take the 2 away from the 2x, you're just left with an x. And if I take a 2 and divide it into the pi, I'm going to have a pi over 2. And then we close our parentheses. Notice if I were to take that 2 and distribute it back into the parentheses, I would get 2x plus pi. So it should come out to be the same thing. And then minus 2. So this is the A, the B, the H, and the K. All right, so we're going to do the same process. We want to set up our box. So for the box, we want to look at the midline. So for the midline, it's at y is equal to the k value, which in this case is a negative 2. We want to find our amplitude. The amplitude is the value of a, which in this case is a 4. We then need to find the left edge of the box, which the left of the box is at x equals, it's normally x equals h. So what is h up here? If I have x plus pi over 2, remember plus means you're moving to the left, so it's actually x minus a negative pi over 2. So in this case we're starting at a negative pi over 2. I need to find the period next. So the period is going to be 2 pi over b, which b is a 2, which means the period has a length of pi. And then we need to do the width, which is 2 pi over our period, and our period is pi, so our width is going to be 2. Oh. No, that's wrong. That's wrong. And so then we need to figure out the width of each of those 4 little parts. And the width is the period, which is pi, always divided by 4. So each of these little tick marks are going to be pi over 4 units apart. So this one's a little different because our x values and our widths and our periods have pi's in them. So when I scale my x-axis, when I label the x-axis, I'm going to have to label it in terms of pi's. And it doesn't have to be just whole pi's. It could be pi's over 2, pi's over 3, pi's over 4 or 8 or whatever. So in this example, let's find the least common denominator. So what's not least common denominator? What is the biggest denominator we have? I have a 2. Here I just have a 1, and here I have a 4. So let's scale the x-axis in terms of pi's over 4. So that means this one here, the first tick mark on the x direction is going to be pi over 4, and then everything after that is just an additional pi over 4. So 1 pi over 4, 2 pi over 4, 3 pi over 4, and we could keep going. And we can also go in the negative direction, so we'd have a negative pi over 4, and then negative 2 pi over 4, negative 3 pi over 4, and we could keep going. Now, one thing to pay attention to, 2 pi over 4 is the same thing as pi over 2. So make sure you understand that fraction there. So we know the midline is at a negative 2. So down here, we'll just go by ones. So up 1, up 2, down to a negative 1, and then a negative 2. So our midline is at negative 2 here. All right. From that, the amplitude is 4. So from that line, we're going to go up 4 units. So 1, 2, 3, 4. That puts me at a positive 2. And then I'm going to go 4 units down. So 1, 2, 3, 4. So it's down here. And 4 units below a negative 2 puts me at a negative 6. All right, so we're going from negative 2 up 4 units to positive 2, and then from a -2 down 4 units to a -6. The left edge of our box is at a -pi/2, which we said pi/2 is the same thing as 2pi/4. So the left edge of the box is at the -2pi/4, and the distance is pi. All right. So what's that mean for the right edge of the box? So what is a -pi/2 plus the period pi? Well, you got to do a common denominator, so -pi/2 plus a 2pi/2, and that's going to turn out to be a positive 1pi/2, which is the same thing as 2pi/4. Okay, so again, here's our box. It's kind of a pretty tall box in this example, and so what we're going to do is we're going to draw in our cosine function inside our box here. We can also look at our tick marks. So our tick marks are each a pi/4, which is the way we scaled the x-axis. So I know we're going to have 1, 2, 3, 4, 5 tick marks just along that midline. Okay. So for cosine, and since this is a +4, it is not reflected. So cosine originally starts in the top left corner in the maximum, and it ends in the maximum. So the two left edges, it's going to be at the top. In the middle, cosine reaches the bottom of the graph, and then it's going to hit on the second and the next to the last point. It'll hit the midline. Something like this is what we get. Okay. Again, the normal cosine graph, if you remember, look kind of like this. Okay, this is cosine, and sine did this. Okay. Well, let's just go through and list our 5 points. So the x-coordinate of the first one, again, it's a little harder because it's in pi's, pi/4. So 1pi/4, 2pi/4, which is, we said was pi/2. So it's a -pi/2, and the y-coordinate is up here at a 2. Now the second point is at just a -pi/4, and its y-coordinate is a -2. The third point is actually on the y-axis, so it's going to be an x-coordinate of 0, and its y-coordinate is a -6. The fourth point is on the first vertical line to the right, so that's at pi/4, and its y-coordinate again is -2, and the last one is at pi/2. So that's the right edge of your box. That's 2 units to the right. And its top is at a +2. So there's what the graph looks like and what the 5 points for that graph are going to be. And again, that's just one period of the graph. If you copied that and then pasted it to the left and the right, you would get this wave that would continue forever and ever and ever. And we just need to be able to draw that one period. After that, you just, again, kind of keep copying it over and over again. All right, the last thing we need to look at is flipping all this around. What if I give you the graph? How do we write the equation? And we're going to use the h and the k versions of the equation just because they're the easiest to work with. And it works pretty much the same whether or not you're dealing with sine or cosine. And it's going to kind of come off of the box that we talked about. Okay, so we want to draw the box. So you got to know what the normal sine and cosine graph looks like. Remember, sine is kind of this, sort of like a sideways S kind of a thing, backwards S, and cosine is more of this valley kind of a graph, upside down bell curve kind of a thing. But again, that's just one period, one section. If you kept drawing the graph, it would start to repeat what's already inside it. So you need to draw the graph, or at least be able to visualize it where it would be on your paper if you don't physically draw. We then can find the value of k. And to find the value of k, we just need to figure out what is the top of the box and what's the bottom of the box and find their average. So take the maximum value plus the minimum value and divide by 2, and that gives you k. Very similarly, we can find the amplitude, and the amplitude is the distance between or half the distance between the top and the bottom. So if you take the maximum minus the minimum, that's the total distance, so you divide it by 2, and that will give you the amplitude, because remember, the amplitude is from the middle to the top or from the middle to the bottom. So max minus min over 2 gives you your amplitude. All right, to find h, it's just the left edge of the box. Okay, so whatever the x coordinate is, that's your h. It could be positive, it could be negative, just depends on where your boxes start. And again, this is usually the hardest part, and it's what is different between whether you're doing sine or cosine. The easiest place to find h, the left edge of the box, is for sine. It's where the function is on that middle and it's increasing. Okay? If it was going down, then you have a reflected graph. So find where your sine graph crosses the middle line and it's increasing. If you did this one here, if it was decreasing, then that would be a negative reflection, which is totally fine. It's just going to change the way your equation looks a little bit. For cosine, we always, if you can, start at the maximum, and then you want to look at where it goes down. If you did it where it's in the bottom and it's going up, then you're actually doing the reflected graph. So always start here in the middle, going up for sine, and then the top going down for cosine. And again, because the graph is, because it's all based off the circle, and the circle goes around and around and around forever, you can start this function wherever you want. So you don't all have to use the same h value. So you may come up with something a little different. It just depends on the strategy you're using. But it has, for sine, it has to be a place where it hits the middle line, whether it's going up or going down. And for cosine, it has to be either the top or at the bottom. That's your only choices. So for sine, it's in the middle. For cosine, it's top or the bottom. Okay? And whether you do top and bottom, just depends on whether it's reflected or not. All right, then you have to, we're not done yet. We've only found k, a, and h. We then have to find the period. There's multiple ways you can do that. Usually the easiest method is just to find 2 consecutive maximums or 2 consecutive minimums on the graph, and then figure out how far apart they are on the x-axis in the horizontal direction. So what's the x-coordinate for the first maximum, what's the x-coordinate for the second maximum, and then just subtract. And that will give you your period. And from the period, the last thing we have to find is b. And we actually saw a similar equation on the previous screens. B is 2 pi over the period. So the period is 2 pi over b, if you know b. If you're trying to find b, it's 2 pi over the period. Okay, and the period is the length of your box, or the width of your box. All right, let's just try one example, and then we'll be done. So let's write out the sine and the cosine equation for the following graph. So our first step is to, in essence, figure out where's the middle of our graph. Sometimes it's actually easier to start with the top, so the top and the bottom. So I know the top of my graph is here at 1, and the bottom is down here at a -5. So I know I have the entire graph is between 1 and -5. So to find that midline, to find k, we said you could do the max, the average of the max and the min. So 1 plus a -5 over 2, and that's going to be a -4 over 2, which is a -2. So the midline is here at a -2. So the middle of your graph goes through -2. All right. We then want to find the amplitude. I think it was very similar. So the amplitude was, and the amplitude is the difference between your max and your min, which in this case that would be 1 minus a -5/2, which turns out to be 6/2 or 3. So let's just check that. From the middle up to the top, how far is that? So from the middle, we go up 1, 2, 3 units. So from -2 to 1 is 3 units. From -2 down to -5 is also 3 units. So again, you can get it using the formula. You can get it using just looking at the graph. So I know the graph goes from has a middle line, the k value of -2, and the amplitude is 3. I'm going to skip h for the moment. Let's look at finding our period. All right, so to find the period, again, I said the easiest method was to find 2 consecutive maxes, which on the portion of the graph I've given you, we only have the 1. Okay, there is another max over here, and it's, you know, the wave of this function is going to continue forever, but I'm only giving you a portion of it. But I do have 2 minimums. We have these 2 here. So what's the x-coordinate for these? Well, if 2 lines, 2 horizontal, or 2 of the horizontal tick marks, 2 of the vertical lines, land you at a -pi, what's just 1? Or then you go in the other direction. If you go 0 and you go 2 lines to get to pi, what's 1 line? Well, it has to be half of that. So this is, each vertical line here represents a horizontal distance of pi over 2. So 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, and then 5 pi over 2. So this one happens at 5 pi over 2. Where's the left one? So we go negative pi over 2, -2 pi over 2. So this one's at a -3 pi over 2. So how far is it from there? So to find the distance, you just subtract them. Do the right one minus the left. So 5 pi over 2 minus a -3 pi over 2, which turns out to be plus, so 8 pi over 2, which is 4 pi. So this graph has been made longer than it normally is. So normally it would be 2 pi. It's now double that. It's 4 pi. Okay. So that means we can find the value of b. And we know b is 2 pi over our period, which in this case that would be 2 pi over 4 pi, or just reduces down, the pi's cancel, and it reduces down to a half. So I know a, b, and k. We just need to find h, okay? And so h is where things change a little bit for us, because h, we can talk about h for sine. We can also talk about h for cosine. Okay, so remember for sine, where did the graph start? The graph should start in the middle of the box. So the middle of the box is where it crosses the midline and it's going up, remember, right? So what is the x-coordinate? This is at negative pi over 2. We already said that. So in this case, I'm going to say h is a negative pi over 2, because that's the closest place to the y-axis where it crosses the -2 line and it's going up. Now I could also use the point way over here on the left at a -5 pi over 2, but it's going down. I could also use the location here at 3 pi over 2, but again it's going down. I could use them, it just means that it's reflected, and so you make your amplitude negative. I want to keep the amplitude positive, so I'm going to use that negative pi over 2. All right, and again, remember your sine graph starts in the middle and it goes up, down, and back to the middle, and cosine starts at the top, goes down and comes back up. Okay, so for cosine, how do we find cosine? Cosine is at the top if you have a maximum somewhere. So I'm going to go with that one here. So this is the one I'm using for sine. Here I'm going to use cosine because it's starting at the top and it's going down. So what's the value there? The x coordinate, we already labeled that was pi over 2. Okay, so the k, the a, the period, and the b values, those are the same regardless of whether you're doing sine or cosine. It's only the h that changes that. Or potentially, depending on what you pick for h, you may have to make your amplitude negative. So let's put all this together and write our functions. So for sine, again, it's y equals a sine of b times x minus h, close parentheses, plus k. So we have y is equal to a, which we said a was 3, times the sine of b, which we said is a half, times x minus h. And for sine, we said h was a negative pi over 2. So minus a negative makes it a positive pi over 2, close the parentheses, plus k. We said k was a minus 2. So that's the equation that would generate this graph if you use sine. Cosine is the same thing. It's just we're going to use cosine instead of sine. So y is equal to 3 cosine 1/2, all that's the same, x minus, so what did we pick for h? We picked pi over 2. So pi over 2, close your parentheses, and minus 2. So the only difference is your h value here. That's the only thing that's different between sine and cosine. And again, we could have picked different points to start. Sine has to just start somewhere on that midline, and I like to pick where it's going up, but you can pick where it's going down. It changes. It's going to reflect and make your 3 out front negative. Same thing for cosine. I usually like to pick the maximum, but you could have picked either of the minimums. It just means it's reflected, so you put a negative in front of the 3.